welcome back to The Explainer. So today we're going to completely rewrite what you think you know about where your food actually comes from. I mean, if you close your eyes right now and picture a farm, what do you see? You probably imagine an old red barn, a dusty tractor, and a farmer standing out in a field trying to predict the rain by looking up at the clouds. But I'm here to tell you that image is totally obsolete. The modern farm has undergone a massive, completely silent revolution. So you really have to ask yourself, just how high-tech is that food sitting on your plate right now? We've got to toss out that whole pitchforks and overalls stereotype, because the reality is far more fascinating. Okay, let's dive into this. Because a modern farm is basically a massive data center connected directly to the stars. Looking at the USDA data, today's agriculture is honestly practically sci-fi. We're talking about actual satellites orbiting the Earth, beaming signals down to autonomous machinery, while digital tablets track the exact chemical makeup of the dirt in real time. And no joke, this isn't some distant future. This is happening right now out in fields across the country.
And honestly, thank goodness it is. Because we are up against a massive global wall here. 9.7 billion. That is the United Nations projected global population by the year 2050. To put that into perspective, feeding nearly 10 billion people means we need an unprecedented explosion in food production. And we somehow have to pull that off while battling crazy production costs, severe labor shortages, and totally unpredictable climates. A food crisis is a real threat, and these high-tech, innovative solutions are literally our only way forward.
Section 1, what is digital agriculture? And just as importantly, what isn't it? The formal definition of digital agriculture is the diffusion of information technologies. So think the internet, mobile devices, and predictive analytics, all used to enhance data-driven decision-making and automation in the agricultural sector. But here's the absolutely crucial takeaway. A farm today runs on predictive analytics and automation just as much as it runs on good old-fashioned water and sunlight. Data is literally the new primary fertilizer.
Now, what's really interesting when you map out the evolution of farm technology is how everything overlaps. On one end of the spectrum, you've got your old analog tools, like paper soil maps. Then, in the middle, we step up to conventional precision agriculture, which brings in electronic yield monitors and variable rate tech. But then we cross over into true digital agriculture. That's the heavy hitter: advanced data analytics, gene editing, and full-on automated farming. And right now, we are living right in the middle of that complex intersection. To really grasp how this plays out in the dirt, think of it as a three-part flow. Step 1 is data collection. This is gathering info using yield monitors on the combines or sensors right there in the soil. Step 2 is decision support. You take all that raw data, feed it into electronic maps and analytics software, and figure out exactly what that specific field needs. Finally, step 3 is input adjustment. This is where the rubber meets the road, using autonomous guidance and variable rate technology to physically change how much seed or chemical is applied to the ground. It's this beautiful, continuous loop.
And this brilliantly illustrates that whole ecosystem. It's an incredibly intricate web of hardware and software working together on the farm. Think about how the data from yield monitors and soil tests cascades down into decision support systems, stuff like yield and profitability maps. And those maps don't just sit in a filing cabinet somewhere, they're fed directly into the machinery to automate physical actions, like section control on a massive sprayer. It's a seamless flow from raw information straight to physical action.
Section 2, the core technologies. Let's take a look inside the cab.
So, picture the old analog way of farming. A farmer would just spray the exact same amount of seeds, fertilizer, or pesticides across the entire field, totally ignoring the fact that the soil quality could change dramatically just 50 feet away. Now, contrast that with variable rate technology, or VRT. VRT lets the equipment customize application rates over tiny distances within the exact same field. It's a total game changer. It saves the farmer an absolute fortune on wasted inputs, and it stops excess chemicals from running off into the environment. Let's break down exactly how farmers are actually using this data, because it varies quite a bit by crop. When you look at the breakdown for winter wheat, for example, 80.5% of those farmers are using their monitors mainly just to track moisture content. But then look at sorghum. A massive 95.6% of those farmers rely on their monitors to perfectly calculate and determine their chemical inputs. The tech is incredibly adaptable to exactly what that specific crop needs. Section 3, the reality check. Who is actually adopting all this high-tech gear? So the crucial point is right here. Automated guidance is completely taking over.
Auto-steer guidance systems went from being used on a measly 5.3% of corn acres back in 2001 to a whopping 58% by 2016, and for sorghum, it crossed 70% by 2019. Think about that. The vast majority of our staple row crops are now being planted and managed by machines that are literally steering themselves using satellites.
And the data collection side is keeping right up. If you track the trends for corn and soybeans, you can clearly see this relentless climb in yield map adoption since the late 90s. Both are now well past that 40% mark for planted acres. Honestly, farmers are just hungrier than ever for spatial data about their harvests.
But it's not just a straight rocket ship up for every single piece of tech. Take a look at variable rate technology. See how bumpy and mixed the adoption is compared to the mapping data? Even with the massive cost savings and environmental perks, VRT adoption is still hovering under 40%, even for a massive crop like corn. The reality is it takes a ton of technical know-how and some seriously expensive equipment to pull off, so there's definitely still some friction there. And that friction leads to what we call the farm size divide. Because the upfront adjustment costs, the subscription fees, the training, the maintenance, are pretty steep. The big operations definitely have the advantage of scale. The data shows that at least half of the larger farms, those in the top 40% by acreage, are using yield maps in VRT. But on the flip side, less than 25% of the smaller farms in the bottom 20% are using them.
Geographically, this creates these huge concentrations of GPS farming. Look at the heavy clustering right in the middle of the country. That's the Corn Belt. Places like Illinois, Iowa, the Dakotas, where well over 60% of acres are managed by GPS. But then compare that to the eastern US. Out there, the farms are smaller, the terrain is trickier, and the crops are different, so GPS adoption stays much, much lower. All right, on to our final section, Section 4, Driving the Digital Shift. Let's talk about the why. At the end of the day, it really all comes down to survival and efficiency. Farmers are making this digital leap to combat some really severe labor shortages. If you literally can't find workers, you have to automate, right? They use it to manage extreme soil variability so they can treat every single square foot of land individually. They're also motivated by financial incentives from USDA conservation programs to farm more sustainably. Plus, they need to maximize their scale, often hiring third-party crop consultants just to crunch the mountains of data for them. So this isn't just about playing with cool gadgets. It is absolutely essential for the business of keeping the world fed.
So I want to leave you with this one final provocative thought. Next time you sit down at the dinner table, just look down at your plate and ask yourself, how many satellites orbiting in space, how many sensors buried in the dirt, and how many millions of data points did it actually take to grow this meal? The hidden high-tech network that sustains human life is vast, it is incredibly brilliant, and it is completely transforming the earth beneath our feet. Keep exploring, keep questioning, and we'll catch you in the next explainer.